Hey, thank you for joining us today for the inaugural episode of the Cloud Security Today podcast, sponsored by Prisma Cloud. In this podcast, we won't necessarily focus on the latest news around cloud security, but rather we really want to go deep into the how side of all things cloud security. My name is Matt Chiotti, and I'm the Chief Security Officer of Public Cloud here at Palo Alto Networks. And our goal for this podcast is to do these really on a monthly basis and pull in experts from all over the community so that you can learn how to do cloud security better. In today's show, we are going to dig into the latest research from Unit 42, which is Palo Alto Networks' elite team of threat researchers. And we're going to dig into their cloud research findings, which came out in the latter part of 2020. We're also going to then dig into a newer research on something called Hildegard, which has to do with cryptojacking. So today I invited on the show Nathaniel Quist, who goes by the very awesome letter Q. I wish I had that capability to do that, go by a letter, and also Chen. So Q, why don't you go first and introduce yourself, and then Jay, and then we'll jump right into it.
Alrighty, awesome. Thanks, Matt. Very happy to be on this inaugural kickoff podcast. This is awesome. As Matt said, I'm a senior threat researcher with Prisma Cloud, also with Unit 42. My primary focus is looking at the who, why, what behind who's attacking cloud and why they're doing it.
How about you, Jay?
In case you haven't noticed, my name can also go by a letter J.
I think I'm going to start calling you that now. It'll just be J and J.
Yes. So my research has been around public cloud and microservice technologies such as container and Docker Kubernetes. So in this episode, I hope to share with the community what I have been looking into in the past year.
Awesome. Well, awesome. Let's jump into it. So you guys do your cloud threat reports about 2 times a year. And I know the last one was focused on cloud native identity and access management. And I think many people, it's been said, I think I heard it probably 2 years ago, that identity is the new perimeter. And when I first heard that, I first thought, yeah, that sounds like somebody in marketing wrote that. But I think the more, and as I looked at some of the research that you guys carried out, I think that's actually true, right? We know that identity and access are really intrinsically connected when providing security to cloud platforms. So in your report, I know that you guys conducted a red team exercise. I definitely want to hear about that. And I think the audience will probably find that really, really interesting. So let's dig into it. So I know that you did a red team exercise and you were able to discover and leverage IAM misconfigurations to own essentially an entire cloud environment. And I read that it could have potentially have been a multi-million-dollar breach. But before we talk about that part, I would like to actually learn about 2 things. One, how do you actually choose your threat research projects? And then the second part of it is then how do you go about executing those projects? Like what kind of tools do you use, the infrastructure? What do you need? Like, so I'm imagining someone's going to hear about the red team exercise. They're going to think, wow, that was awesome. They're going to know, how do I carry that out along my own cloud environment? So Q, I'll start with you. Maybe talk a little bit about how you choose projects and what your setup looks like.
Yeah, perfect. So yeah, so 2 kind of aspects, right? So choosing how we're doing this. Every threat report that we do, we focus on a specific topic. This last one, as you said, was IAM. The report before was infrastructure as code. So we looked at different aspects of that. And then what we do is we do some research, we formulate our analysis, collect a whole bunch of data, do some analysis on it, and then present our findings. So specifically within identity and access management, we were actually presented by a client. They said, would you want to do a red team exercise in our environment? And being Unit 42, we're not like a red team sort of group. We are more threat intel, threat research. What are the risks that we find within this field? But it was interesting. I mean, no one's really done it to a great scale, and we wanted to see if we were already focusing on identity anyway. So let's just see what we can find. So it kind of brings us to the next phase of, well, how would we actually do a red team exercise? And first off, obviously we need knowledge, right? I mean, Jay and I have been doing cloud-focused research for quite a while. Jay's been doing it a little bit longer than I have when it comes to like containers and Kubernetes and Dockers and things of that nature. the exploits within. I'm focused more along the line of the threat actor groups, how are techniques garnered, MITRE attack frameworks, things of that nature. So what we did is we wanted to figure out, well, how do we actually do this sort of attack? So obviously books, knowledge, gathering intelligence from a lot of different sources. I have a pile of books right down here. It's amazing of what would it look like. And then we start talking about what is our scope. What is that scope of that attack? We talk with the client that was interested in working with us and figure out, are we going to go from an outside in? Are we going to have limited access inside? And then what is the ultimate goal?
What was the ultimate goal for this time around? I know with this specific report, did the client restrict you and say, there's, you can't do this. Obviously, they wouldn't want you to run like a DDoS against their environment, but what did that look like?
So again, it was very cool that the client approached us. They were very engaged and willing to kind of go with where we wanted to go with it as well. It was kind of open-ended. We kind of started out with no access. We just wanted to do kind of a perimeter, recon on it. What could we actually find from a cloud perspective in that environment? And then how far could we go into it? So we did a little recon on it. Jay found a really cool way into the environment with unauthorized access, just being able to peek inside of, specific containers. I'm sure we'll get into that here in a second as well. But we just kind of we scoped it out saying we want to do an external view on it. And then we then worked with the client again, changed scope and said, let's do a little bit of internal access, not full access, just like specific developer access. And then how far could we go? Could we actually get to the point where we own the entire system? And they kind of left the reins open and we just kind of ran with it. And sure enough, we were able to get root access to the whole cloud environment. And it was really fast. Only within a couple of days, we were able to do that.
Do you guys get these kind of requests often, like to pen test environments, to red team cloud environments? I know you said that that's not what Unit 42 typically does, but just curious.
Yeah, we have been approached a few times and we have said no to a few clients. So, just because it isn't our focus, but this was kind of a special one-off, I guess you could say.
Awesome. So Jay, from your perspective, I know that Q mentioned you've been doing this for a while, but I'm curious, before we actually get into some of the findings from the recent threat report, how have you approached, maybe not even this specific project, but when you've done some threat research projects in the past, I know that you've got a lot of research on blockchain and things like that you've done in the past, but how do you typically approach your projects? Like, what's your setup look like?
For me, I usually look at the trend of the industry, like what people are interested in, what people are looking at, what are the hot topics, what are the latest technology that people are talking about. 2 years ago, in early 2016, blockchain, Bitcoin was a hot topic. It died down. Apparently now Bitcoin is it's hot again, but I'm not looking at it anymore. Too bad. Yeah, so at that time, I look at the blockchain, and in 2017, when people start to look into the use container, when Docker first emerged and followed by Kubernetes, then I look at this new technology first. I understand how it actually works, how the engineers, how the DevOps actually use these tools, then I start to dig into the security to see what are the attack vectors into this new technology, what kind of mistakes that people tend to make. I'm not a real vulnerability researcher. I don't look into the software vulnerability. I don't look at the source code, but typically I look into how we can make a specific technology more secure and look into what mistakes that people tend to make that make this technology insecure.
That's an interesting approach. So I'm curious. So Jay, while you're kind of talking about that, so I know that you had found some IAM misconfigurations in the one client that Q was talking about, but then you had done some separate research around the issue just to make sure there was, how widespread was it? Maybe before we jump into that, let's talk about some of the high level findings from the report. And Jay, maybe start with you. When you looked at all this research, I know it wasn't just one red team exercise, there was actually the broader industry as well. But what was most interesting to you in the report? And we'll put a link in the show notes to the full report. But Jay, from your perspective, what was most interesting?
For this particular report, the latest report that we published 2 months ago, focusing on IAM, my biggest surprise that even in a multi-million dollars enterprise environment with thousands of workloads, thousands of EC2 instances and databases, like they still make very fundamental mistakes. These mistakes that we all have heard about, we all know, but people are still making the same mistake, like from the first day that public clouds are available. My biggest surprise is that I know at least more than 200 engineers are using this cloud environment, the particular cloud environment that we pen test. More than 200 or close to 300 engineers are using it every day, but everybody is focusing just on the specific service that they are using by day to day. But nobody seems to oversee or look at the entire cloud security comprehensively enough to spot this very simple misconfiguration that allow us to gain the entire to take over their entire cloud completely from unauthenticated user to the like almost root user privilege.
We've been kind of beating around the bush. So how did you actually get in? What was the vector? What did they do wrong? What should they have done differently? Let's get to the specifics. Like, what did you actually find?
We look at multiple cloud environment, multiple AWS accounts specifically. But in one of the account that we look at, we found a specific IAM role that allow an authenticated user to access. So using a traditional SH server as an example, this is like you have an user inside your SH server that can be logged in without a password. As long as you know the username like J-A-Y, and you can just type the username, enter, then boom, you are in. So this is the same type of vulnerability or misconfiguration we found in this particular environment. The client has multiple IAM roles that are not restricted, meaning that they can be used by anyone. And as long as you know this role, then you can gain this role and you can start to access the cloud environment. So this is one of the worst misconfiguration you can have. And unfortunately, yeah, we found more than one this type of misconfigured IAM roles in this customer's environment.
This wasn't like a typical, they had like a weak password. It wasn't like username and password and someone's password was God or, whatever, like a 3-letter. So, I mean, Q, from your perspective, is this something that if they would have had, multi-factor authentication turned on, would it have helped in this case?
Sure. Well, in this, like as Jay said, if all you had to know was the username, that's all you had to know, and then you just requested access into that particular, environment. If they put in, even just putting in require a password, that would have, done something. But then if you add just that second level of multi-factor authentication, 2FA, using your phone or a YubiKey or whatever you want to use, it just increases the difficulty in accessing that. That's like, a lot, amazing exponentially. So just, you need to have a password, and that's something that they just didn't fail to put in.
So I was looking at the report, and it says that you were able to do this by exploiting a single misconfigured IAM trust policy. So maybe for people who are not kind of familiar with, this is, I think, AWS specific language. What is a trust policy or a role trust policy? What does that do? And what was the actual misconfiguration?
The concept of IAM role in AWS is similar to other role-based access control.
It's a best practice, right?
Right, it's a best practice that you set up multiple role, and each role can be used by a specific group for specific functions or job. And it's the same as in AWS. You set up multiple roles, and the way that a user can use this role is by assume a role. So for each role in AWS, you need to attach something called trust policy to this role. And what this trust policy does is that it restricts the entities that this particular role can trust. It essentially defines who can use this role, who can access these roles. So you can define, hey, this role can be used by another AWS account, or you can define in a way that this role can be used by this particular AWS service, such as Lambda, EC2 or EKS. And you can also restrict this role to only be used by a specific user in your account, like J or Q, Matt, if we are in the same department. And for this misconfiguration, we found the particular role has no restriction at all, meaning that this role can be used by anyone, even users in other AWS accounts.
How did you find this to start out? Did you go directly after the account, or did you have to bring up your own kind of AWS account and you went through some kind of long brute forcing process? What did that look like?
We did some reconnaissance, right? We were able to find out the 12-digit account IDs of these customers. So each AWS account is uniquely identified by a 12-digit account ID. And the next thing we need to do is to find out the existing roles in this AWS account. And we did some reconnaissance that we actually scraped the internet for that particular customer. We look at their GitHub repository to see how they use this cloud account, what are the roles that exist in this particular account. So to emphasize, roles are typically not considered as a secret. I can safely give another person or another company a role and let them access my cloud infrastructure. So a lot of times, these role names are public information. So we were able to identify a set of roles, and we start to test this role and found out that some of them are misconfigured and can be accessed anonymously.
Q, from your perspective, obviously you played a big part in this research as well, and you've done this for the last couple of years under Unit 42. What stood out to you specifically around identity and access management? What kind of jumped out from you from just some of the statistics that you pulled together? What was interesting?
I guess to me, it's interesting in that I think cloud has the potential to be, or cloud environments just in general have a potential to be so much more granularly controlled than just a normal on-prem environment. From the outside looking in, it's very complex. Complexity can breed some sort of obscurity within cloud environments. So you kind of get this kind of warm feeling that look, it's so complex that it's obviously very powerful and futuristic and all that fun stuff. But it's within that complexity veneer, within all those different granular aspects inside of it. I mean, it breeds the capability that there's just something that you're going to miss, just one thing that you're going to miss, and it's exactly what Jay was just describing right there. I mean, it's a very simple, if you look at it directly, if you take it apart and say, well, anybody can access this role, from anywhere in the world. It's just kind of like, well, that's obviously a security risk. But it's just cloud providers, and no fault of their own, are trying to make cloud accessible and easily usable to breed, adoption and have people go to their platform. And that's great. But there's tricks that are in there, like the asterisk. I absolutely hate asterisks in cloud environments because it means everything.
So when you say an asterisk, like a wildcard, what do you mean you hate to see those you mean in configurations for IAM?
Correct. Yeah. So like the trust policy that we found that Jay was just talking about right there was the trust policy itself is which AWS accounts or environments can access this role, this role, and it was an asterisk, which means anybody can access it.
That's like the equivalent of in a firewall policy having any, right?
It really is. So I mean, but you can make the trust policy so granular. You can put it down to where I only want this particular person from this particular environment to access this role. That's it. I only want this one service from this one environment to access that, and you can specify specifically that. With cloud environments, I mean, from a security perspective, if you are going to do the compliance checklist and go down the thing and say, how are all these configured? You want to be able to specify every single role that you want to access that and no more. I mean, the least privilege principle is what we want to, aspire to and have made. But every time you put an asterisk in it, just makes it to where anything within whatever that value, then anything else after it is allowable. And that kind of brings us into the next finding within this particular role, which was, we just talked about the outside in, if we're going to go from the inside up, we had limited access to an environment. We were able to, just by enumerating the roles, enumerating the permissions that this one role had, we found one specific IAM role that allowed administrative access. Once we had that, All we had to do was assign that one role to a new instance that we could create, and then we had full access to the entire environment. But it's all because of there was a little asterisk that said, you can have everything.
Prisma Cloud is a comprehensive cloud-native security platform with the industry's broadest security and compliance coverage for applications, data, and the entire cloud-native technology stack throughout the development lifecycle and across hybrid and multi-cloud deployments. The integrated Prisma Cloud approach enables security operations and DevOps to stay agile, collaborate effectively, and accelerate cloud-native application development and deployment securely. Start your free trial today by going to marketplace.paloaltonetworks.com. So there was two types of scenarios that you carried out in this red team exercise, right? There was from the outside in, so you're posing as somebody who's just any person that has an internet connection, right, can do that. And then you said inside up. So that must mean did they give you like direct remote access into the environment, like username and password? What did that scenario look like?
Sure. So yeah, I mean there is a nuance, and thanks for spelling that out. So yes, there's we had two access. One was no access whatsoever, and then everything we found was just recon that we did from GitHub and all that stuff. And that's what Jay was just talking about. And then the other aspect is we had limited access to environment. And by limited, I mean we had developer access. And developers traditionally are able to start processes. They're able to change, access networking routes and things like that inside of environment. What's very important about this is we had developer access to only a very specific small AWS environment, just an environment in their full infrastructure, just that one little piece that the engineers themselves, the developers, were able to use and test products. Like I want to test some new tool or some new gadget that they're building. So we had access to that.
Okay, that makes sense. So that's that inside up scenario. And if I understand what I read correctly, so in both of those cases, both which you guys found from the outside in and the inside up, in both of those cases, it was the misuse of a wildcard in the IAM configuration that allowed you to get in, but you still had to find it. Now, so Jay, from your perspective, when you're finding these things, are you using some kind of, are you exploiting some kind of, 0 day? Are you writing some kind of new tools for this? Like, I guess what I'm getting at is, if I'm somebody listening to this podcast, I'm starting to think, oh my goodness, is my cloud environment susceptible to this type of attack? What do you recommend? Like, how does someone go about trying to find these types of misconfigurations in their cloud environments?
Oh, unfortunately, no. I didn't use any 0 day.
Oh no, that would have sounded so much cooler if you just said it.
I don't have any 0 day. Yeah, sorry about that. Yeah, that's not as exciting, as fancy as what everybody thought about pen tester. But I'm not as Chris mentioned, we are not real pen tester. This is not our day-to-day job. But I'm sure most of the pen tester will agree that when they go to a client's environment, 80-90% of the time they look for misconfiguration. Most of the time they just gain access to misconfiguration instead of using any 0 day or using any vulnerabilities. Like I don't think usual pen tester will have 0 days or can exploit 0 days in a client environment. Usually you don't need to go that far. You just need to find one misconfiguration, and that can start your journey into client's environment.
I've looked at some of the previous reports that you guys had put out. It seems that if I remember one statistic correctly, it was that 65% of, I believe it was all security incidents in the cloud, are the result of customer misconfigurations. 65%, so the majority. So you guys didn't use any type of 0 day to do this, both inside and out. You just used a misconfiguration that doesn't require any kind of special code to execute. You didn't have to go onto the dark web and try to find some kind of great tool to do it. So this really puts two questions in my mind. So I read, Jay, that after you have found these IAM misconfigurations in this one client, that you actually did some separate research to find out just how widespread the issue was in the industry. What did you find? Is this just like one client who had a really bad day, or is this like more common?
Yeah, so for the misconfigure IAM roles that I mentioned earlier, so there are different ways that you can identify the existing roles in the customer's in the cloud environment. You can search on Google. You can look at the GitHub page of that customer to find out the roles. And another way is through enumeration. So this is a known technique that published, I think, almost 2 years ago. And there's a way that you can enumerate, like as an outsider, there's a way that you can enumerate the existing IAM users and roles in a cloud environment. So this is a known technique. So for when we conduct the rating exercise, I actually use this technique to enumerate the customer's cloud account and to identify the misconfigured IAM roles. But after the rating exercise, when I try to understand how widespread this issue is in the wild, I try to look through GitHub, trying to find as many AWS accounts as possible, and I try to look into them, trying to enumerate, trying to identify the roles in those accounts, and to see how many of the customers have misconfigured IAM roles. And the issue that I encountered was that this enumeration process is very slow. AWS restricts how fast you can abuse this particular API to enumerate the existing IAM roles or users.
I'm curious, right? So as you're doing this, to me, this sounds almost like, what we would have done historically with trying to brute force like a password or something like that. And as you said, I would imagine, the cloud service providers, they spend billions of dollars on their security, right? Making sure that their platforms are secure, that they do things like API rate limiting, right? So it was AWS in this case, but I'm sure any cloud service provider is not going to let you just go crazy and just enumerate. So what kind of protections do in this case, it was AWS. I mean, how did you stay under their rate limiting? Like, how did you go through? Because I'm looking at the report right now. I'm just kind of scrolling through it, and it looks like you really leveraged public data from GitHub. And, I see you went through almost 283,000 files, nearly 150,000 source code repositories. And it looks like you scraped from that about, almost 70,000 role names and almost 33,000 potential AWS accounts. So, you mentioned that it would take a long time. Like, how did you go about carrying this out? Was there a tool that you used? What did that look like?
There are several ways that I try to accelerate this research. So enumeration is my last resource. I start from Google, just use Google docking to identify the roles in this particular account. And I scrape GitHub, I identify all the repositories of this particular associate or related to this particular AWS account ID, and I try to parse out all the possible role name. So I did everything else, and usually I can find at least for each account ID that I found in GitHub, just by looking at the related project, I can find at least 5 existing IAM roles already. Then the last resort I had to do is to enumerate. And for this purpose, in order to enumerate fast and in large scale, I had to develop another tool called IAM Finder. So for this particular tool, I identify a set of AWS APIs that can be abused. They are not vulnerable. So I'm just using those APIs in a way that were not expected by AWS.
I want to double click on that because you're saying, so you found a way that you could use an AWS API in an unexpected way. What does that mean? It sounds like I want to make sure we pull out that nuance there. What does that actually mean?
So there are 2 types of security policies in AWS environment. There's resource-based policies or permission-based policy. And my particular finding is in the resource-based policies. What resource-based policy means is that for each resource, such as S3, when you have an S3 bucket or when you have an EC2 instance, you can attach a security policy to this resource. If you have 10 S3 buckets, you can have 10 different resource policies attached to each of these S3 buckets. And there are APIs that allow you to configure these resource-based policies. meaning that you can use this API to upload a policy, usually written in JSON format, and attach to a specific resource, such as S3 bucket you create. And so S3 bucket is just an example. There are, I think, I identified around 26 different AWS service that all support resource-based policy. And all these APIs can be abused the same way. And I'm using S3 buckets as an example. When you upload a policy in JSON format to the API, the AWS API backend actually try to verify your policy. One part of the policy is to specify who can access the S3 bucket that this policy attached to, similar to the IAM trust policy that we explained earlier. So for this particular part of the policy, you need to specify, hey, Q has an account in 1234, and I want to allow him to access this S3 bucket. And I need to put down, again, never use asterisk to allow anyone to access the bucket. A good security practice is always restrict the access to particular resource to the users or entity that absolutely need it. So one very nice feature of what AWS does is that it helps you verify that the identity or the principal you put in the policy is valid. So I have an AWS account and I create.
Is it responds with like true or false? Like, is it that's what you mean by evaluating it?
Evaluate means that if I have an AWS account and I want to share one of my S3 bucket to Q, and I specify in my resource policy that, hey, Q in his account 1234 can access my bucket. But if I accidentally type his name wrong, instead of Q, I type J. And J is not a valid user in that account 1234. AWS backend will give me an error message telling me that, hey, this user does not exist. So this is a very nice feature that help client write a valid policy.
That's really user friendly for the, for a valid user, but someone who's just trying to go through and enumerate, they can just keep trying things, waiting until they get a correct response.
Right. I know Q's account number, but I don't know what are the users in that account, and I can start to try out a word list, 1,000 of different names, and eventually I can find out a set of users exist in that account. And that's essentially what I mean abuse, because that is a very a user-friendly feature to help user write a policy, but the way I use it is not what I expected.
Yeah, it's also attacker friendly. So the IAM Finder tool that you wrote, I know it's open source, that people can go out and get it on GitHub. It's IAM Finder, all one word. They can find it on GitHub. I assume that tool, it leverages that nice feature that you were just talking about, and they can also use it then to kind of survey the security of their own cloud accounts.
Right. So the one nice thing about that tool is that although I found 26 AWS service can be abused the same way, or 26 AWS APIs, but I implement, I think, 5 APIs. And I also, in order to scale up to get around with the API limit throttled by AWS, IAM Finder also allow you to put in multiple AWS accounts. So instead of using one AWS account to enumerate, you can use 10 AWS accounts, which essentially increase your enumeration rate by 10.
So you kind of proved out that these identity misconfigurations, you found this really glaring one in this one specific client that you did a red team exercise for. But then, Jay, as part of your broader kind of look across the industry, you actually found that there are probably hundreds or maybe even thousands of other cloud accounts out there that have similar misconfigurations. So I saw that, in the report, I think it's on page 14, said that you guys found more than 175,000 EC2 snapshots that you could have accessed, hundreds of S3 buckets. Let me ask this, and then we'll kind of jump over to another topic. Maybe each one of you, if you could just give one thing that you would recommend, anybody who's listening do to kind of prevent these types of attacks or to prevent these types of misconfigurations. Q, I'll start with you. What's one recommendation that you would make?
Scan your cloud environments. Use
IAM Finder to scan your own cloud environment before before an attacker uses it.
There's a number of open source tools. There's a number of tools like Palo Alto. Obviously, we have like infrastructure as code scanning. Being able to use some sort of cloud native security platform that is able to scan your environment to see if you have misconfigurations in your environment. Granted, the cloud environment that we found these in, they're using cloud native security tools to find stuff. But I mean, when it comes to just configurations, I mean, having a tool, being able to use infrastructure as code scanning, being able to use some sort of third-party app to look at a cloud environment and look at all these misconfigurations for potential misconfigurations is a huge step in making sure that your cloud environment is configured properly. Because I mean, there's hundreds of thousands of potential avenues of potential misconfiguration. And so having some sort of automated tool go through that and look at it all, from an automated perspective, a machine's going to catch things that humans will just miss.
Especially probably with cloud scale, right? I know at least most customers that I talk to, clients, they've got usually, they don't have like a single cloud account, right? They usually have hundreds of cloud accounts across 2, 3, 4, 5 different cloud providers. So it'd be difficult. Jay, from your perspective, what's one thing that maybe you would recommend? You're a threat researcher, so you kind of get to sit on the other side of the table where you get to go out and find all these things. But if you were in the position of a defender, right, someone who's just trying to make sure that their own cloud environment's in a healthy, secure shape, what's one thing that you would recommend they do?
Particularly in IAM, I will suggest to audit your IAM users, roles, and groups periodically. You keep only users who are active and remove all the users who are inactive. And periodic audit the permissions of each user and roles. Follow the principle of least privilege. If these roles only need to access 3 AWS feature service, don't give it 10. And another easy way to get around with the particular IAM issue that we mentioned is to use federated IAM access. Instead of creating a user for every developer or create a role for every developer, use federated access to minimize your IAM attack vectors.
Well, I appreciate that. So, I thought we would maybe jump into one other topic and then we'll wrap up for today. So one of the other things that I read about that I think is, Jay mentioned at the beginning, anything having to do with cryptocurrency is like top of mind. It's in all the major news now. Back, Jay, when you were looking at blockchain a couple years ago, I think it just wasn't really in the, if I asked my dad, what's Bitcoin, 5 years ago, he would have no idea what it was. But today I know he's got his own Coinbase account and he's got some Bitcoin, right? I don't know how many, but maybe more than one. I don't know. But, so I know that, Q, you've established a reputation in the industry for really closely following cryptojacking as it applies to the cloud. Just, real quick, what is cryptojacking and what did you find in some of the latest threat research around that?
Okay, so first off, cryptojacking is the malicious use of crypto mining. So crypto mining is the process of either finding specific cryptocurrency coins, tokens themselves, or the process of validating those coins are actually proven. So if there is a transaction that happens, you can prove that was actually a valid transaction that should go onto the ledger or not. But the actual process of finding the actual token itself is the process of what is considered crypto mining. And then taking cryptojacking is just, like I just said, just the malicious use of that. Performing those operations on some other infrastructure that you don't own, using someone else's essentially electricity to provide you with profit.
So it's the malicious cryptojacking is the malicious use. And we know that the thing about cloud that I would imagine that attackers love is the fact that there's this almost unlimited compute capacity, right? And we know with crypto mining, there's proof of work where you have to you do complex mathematical computations to prove, right, certain things. And then there's proof of stake, which, some other the different blockchains applications use. But so in this case here around cryptojacking, what did you find, from a trend perspective? Is this really common? What did you guys see?
Yeah, so there's a few commonalities. There's a lot of cryptojacking operations in existence. I've found like 13 or 14 just within the last year of different operations, and the vast majority of them are really operating. They have like kind of the same tactics, techniques, and procedures where they scan for exposed systems of specific types of services. It kind of varies. They get into that system, and then they essentially kill all the other miners that are out there. If they're on that system, if they were compromised before, it kills all those known systems, and then it installs their own system, and then they start cryptojacking on top of that. What's really interesting, and this kind of goes in line with what we were just talking about with identity and access, and this can tie into Jay's latest blog that he just reported on as well, was this group called Team TNT.
I want to know how they come up with their names, because that's pretty awesome.
It is a great name. I mean, it's like, yeah, we're Team Explosive. This is awesome.
Team Explosion. Yeah, I love it. No, I'm sorry. Go ahead.
It's interesting because Team TNT actually stole a lot of their code base from another group called Kinsing. Well, it's amazing. Like if you're looking across like all those different kind of crypto groups that I, there's like 12 or 13 just within this last year that I found, is that within the same block of code, you'll find the exact same. It's like this actor just copied this block of code and put it in their tool, and then another actor copied that block of code and put it in their tool. So it's just like a whole bunch of sharing that's going along. It's kind of funny. But what they're doing that's really interesting is Kinsing and Team TNT both follow very, very similar TTPs. But one of those tactics are once they compromise the system, it's actually the very first thing they do after they compromise that system is they scrape that compromised system for its internal data. They're looking for what type of passwords are already on that system. Can I grab SSH keys? Can I grab, what type of passwords or usernames are on that particular system? But what's really important is that they're specifically targeting now AWS configuration files on those particular compromised systems. So if you are able to grab that AWS configuration file, you're able to find the configuration and the credentials of users of AWS accounts that can log into that system. So if we go back to what we were just talking about with IAM roles, misuse, misconfigurations, whether you have assumed role or you can pass roles on to other resources that you may have access to. If we have an actor group that is now compromising hundreds of thousands of cloud accounts across lots and lots of different environments, and they're grabbing AWS configuration credentials from every single one of those systems, they now have IAM or identity and access credentials to those cloud environments. If they're able to access that cloud environment and they are able to misuse perhaps a pass role feature, or if they can assume a role now that they know which one it is, and that particular client is vulnerable, then they could have larger access to the cloud environment, not just the compromised host.
How prevalent is this? I was looking at some of the older research. It looks like you first started tracking this back in 2018. Is it more common now? Like what are some stats around cryptojacking?
It's actually very big. During this report that we're just talking about here, is that 23% of all cloud organizations that we can see, 23% of them are experiencing some form of crypto mining operation network connectivity. So that means that nearly a quarter of every environment is communicating with a known crypto mining platform.
Is there a valid reason for that? Like I know in a lot of the research, you tend to hone in on Monero, which goes by XMR. That's kind of its 3-letter piece. But is there a valid reason that company X would have traffic going to these, or is this all usually malicious?
We've been proactive and we've reached out to some clients and we're saying like, hey, we see that you may have some crypto mining operations happening in your cloud environment. And we've actually been told on more than one occasion that that's okay. We're aware of it. We're doing this on our own. So it's kind of like, well, I mean, if you want to mine, sure. I mean, the price of Monero is going up. It's going up pretty dramatically, kind of matching that Bitcoin march up to 51,000 yesterday. So, and depending on where your electricity is and how much it costs to pay for a compute cycle within whatever cloud environment you're using, maybe there's a cost benefit that you could do that, or you're looking for an investment opportunity. Maybe an organization is doing that. But I want to caveat this with a really big caveat, is that Monero, specifically Monero, is a criminal favorite cryptocurrency. If you were going to mine, you might want to pick an easier mine like Ripple or something else that you'd want to mine with. It's easier to process, or maybe has a better, more highly favored legal history or usage behind it. Monero is very Criminals love it for a lot of reasons. So when we're seeing Monero mining happening in the environment, I just don't know if that's legitimately true or not.
It's probably very different than if it would be, Bitcoin, which seems to be adopted by, I think it was just last week, Tesla announced that they invested, I think, $1.5 billion of their treasury into Bitcoin. And then, so probably if you see Bitcoin mining, Ethereum mining, it could be legitimate, but Monero is probably not legitimate.
Yeah. I just want to say, if you are mining Bitcoin on a cloud, you're doing it wrong. Just don't do that.
You're paying probably way too much. I also saw from a Bitcoin perspective, I saw that one of the Russian oil companies announced that they are starting a Bitcoin mining operation in Serbia. Or Siberia rather. So anyway, well, I've really enjoyed having you guys today on the podcast, especially being our inaugural podcast. So thank you both for joining today. So again, our goal with these podcasts is to do them on a monthly basis. So if there is a specific cloud security topic that you want to learn more about, please drop us a DM on Twitter. It's at CloudSecToday, at CloudSEC Today. That's our handle on Twitter, so you can reach out to us that way as well. Also, a call to action would be to download the free IAM Finder tool, and you can scan your cloud environment and look for common IAM misconfigurations. Again, it can be downloaded directly on GitHub by searching for IAM Finder. Thank you so much for joining us today, and have a great day.